In now already second unit is completed. We are going for the third unit, that is a processing unit. In that, first concepts which is we are going to see, that is basic concepts of processing unit. Before going to this unit, I will give you one brief. Already, I think exam coordinator has forwarded the timetable of your CE1 exam, which is of 2 units. For the 2 credit also, 2 credit course also, 3 credit and 4 credit course also, which is on coming Friday and Saturday. On coming Friday, 2 papers are there, and on Saturday, 1 paper is there, CE1 exam. Okay. That schedule, if it is not sent on your group, it will be sent soon, as soon as possible. That is the one thing. That is up to second unit. We are having an examination on C1. Now we are moving to the third unit. That is a basic concepts of processing unit. Now, if the in first unit itself, we have seen the like this diagram only for the processing unit. In that, processing unit is nothing but the central processing unit. That is a brain of computer. We can perform the n number of tasks. For example, this processing unit is input is provided to the input devices. For example, keyboard and mouse. And whenever the processing unit perform the tasks or operations, that result will be displayed on the output devices. That is a monitor. That is as a display device. Now, what is the structure of the central processing unit, which is shown in this diagram? It consists of the, you can say that the 5 blocks are there. One first block is input devices, that is you responsible for the giving input to the processor. Output device block is responsible for the display the output of the screen. Then the next block is internal memory and external memory. This internal memory and external memory attached to the central processing unit, which will be responsible for the storing the data internally on internal memory, or if you want to store that externally, it will be stored on the externally on the external memory. Now we are moving to the main block of the CPU, that is a central processing unit. That is, in short, we are saying that CPU. This central processing unit consists of the 3 main blocks. First one is control unit, which will be responsible for the controlling all read and write memory and input output device related operations. This unit is responsible, and it is going to generate the control signals for the reading and writing operations of memory as well as the input output devices. Now next block is arithmetic logic unit, which will be responsible for the generating the output of the arithmetical and logical operations, like arithmetic operations like additions, subtractions, multiplication and division, and logical operations like one's complement, two's complement, and or XOR. These are the logical operations which will be done with the help of the arithmetic logic unit. That will be a second block of the central processing unit. So inside this central processing unit, another block is that is a memory. That in that memory, it is having the 2 types of memory to hold the data. First one is registers. Now, registers are responsible for the holding the current value of data as well as the after result is generated, that will be stored in the register. Then second type is cache. Cache is a memory where it will be holding the temporary data whenever we are performing the operations. So any processor is having cache memory, that means it is it will require a less time of execution. That is a working of central processing unit. Almost first unit which is we are doing, same explanation is here. My voice is not audible. Hello, my voice is not audible. Okay, I will MCQ type, or Rohit Dole is asking about the CAE1 exam. Okay, that is a subjective exam. We will share the question paper on your Google Classroom. Through that classroom, you can access that question paper. You have to write down, even answer sheet format is also shared on your Google Classroom. I have shared what format you have to maintain on the simple plain paper. You have to draw that format before examinations. and you have to write down your roll number and name, all these things. Subjective type paper is there. You have to write down the answers on that answer sheet paper only. And after that, you have to scan that document and say upload Google Classroom itself. That is the process for the all subjects. And if you, anyone is having now or even today, we are going to send the all email IDs to the Nagpur to create the new email IDs for Raisoni email IDs for the students. Those who are having problem for this year, you can get the new email ID or activation of the all email IDs done. Don't worry for that. Okay. My audio is not coming, so that okay, audible. I think this diagram, all of you understand, or I need to explain again? Please put it in chat box. I need to explain this diagram. Okay, I will explain. Okay, repeat. This diagram represents structure of the central processing unit. Processing unit is nothing but a central processing unit in the terms of the computer systems. Now, these processing units consist of the 5 blocks. First one is input devices. This first block, which will be responsible for the giving input to the processor. Either for that you can use the mouse or keyboard for the input device to give input. So this will be a first block which will be give the input for the processor. Now next block, which will be responsible for the displaying the output after performing the operation on this central processing unit. Now next block is internal memory. This internal memory, third block, which is used for the holding the data as a or information of that particular central processing unit, which it has done some operations. It will be hold that in the internal memory. If not, you can store that same data, internal memory as well as the external. Also, external memory is provided for that purposes to store that data into the external memory. Now, as we have seen that central processing unit, in short, it is called as a CPU, which consists of 3 blocks. Block is control unit. Control unit is responsible for the controlling the operations related to the input output devices and memory related operation, read write related operations. It will be responsible and we generate it according to that signal. This is the job of the control unit. Now next block is arithmetic logic unit. In short, it is called as a ALU, that responsible for the performing arithmetic as well as logical operation. Arithmetic operations like additions, multiplication and division, and logical operation like and or XOR operation, which all these logical operation will be performed with the help of this. Now next block is memory block. Memory block is having the 2 parts. First part is uses the number of register. For example, which is we have seen A register, that is an accumulator, which is holding the current result of the particular operations. B, C, D, E, H, L as a memory register. These are the register which is a part of memory. And next part of memory is cache memory. Cache memory is responsible to hold the current value, or you can say that it is holding the cookies of the particular operations to do the faster operation for that purposes, to reduce the execution time. That purposes this the CPU structure is used. Now understand, we will see the actual working. Block functional operations of the control unit is mentioned with the with the help of this PPT. What are the different functionalities which is provided with the help of this control unit, which is mentioned here? First functionality is that it will be coordinate the sequence of data movement, that data movement in the into the processor to memory, memory to processor, or in between the two processor, or in between the two units of the or many units of the processor. So it is written that it consists of sequence of data movement into, out of, and between processors and many subunits. So we, for that, I will break the statement. In central processing unit, coordinate the sequence between the data movements of, first thing is memory to memory, memory to processor, processor to memory, and processor to the sub many devices. Like this it will be performed. That is the meaning of the first statement. Now next statement is it the instructions. Whenever any interrupt is occurred, that interrupt operations will be handled by this control unit. So next one is control data flow inside the processor. We control the data flow in between the processors. For example, just now I processor to memory, memory to processor. This data transfer or control will be done by the processor unit. Either you can perform the read operation or write operation, R or W operations, which we are going to perform. That will be done here. Now next statement is it receives the external instructions or commands. As we have seen in a previous block diagram, input devices is giving input to the control to the external instructions. It will be give the, through the input devices, we will give the instruction or commands to the processor, and it will be converted into the sequence of the control signal. It will be converted. That is the job of the input devices through which we can give the input and processing unit perform the task. It will be control the many execution of the operations. In the CPU only we have seen the two units are there. That is the arithmetic logic unit, and the second one is control unit is there. So control unit is controlling the operation, and ALU unit is performing the arithmetic and logical operations. That result is stored in the form of the data, or registers are used for the storing that data. That is a part of the memory. All these components are comes here. Now it will be handling the multiple tasks. For that multiple tasks, we need to fetch, decode, instructions, and handle the result. We need to sort that particular result in the form of the final conclusion. So all these results, all these operations, which I am going to explain with the help of theoretically, we will going to see with the help of the diagram. All of you understand this? For next. Now, next is the simple components control unit. Different simple components are there in a control unit. This diagram indicates total control unit. This will be a diagram for the control unit. Okay. In that, what is that? First one is instruction register. What is the job of instruction register? That is from input devices. Whatever instructions we are giving, that is stored in a form of the instruction register. That instruction register gives command to the control. According to that control unit, flags are set, a clock will be sent, and control unit is going to generate the control unit for the control signals for the CPU. Then after generating the control signals, this control bus comes in existence, and it will be perform that particular task, and it will be send the control signal to the control through the control buses to the control process unit. Then after that, again, if you want to send the multiple tasks, again it will be sent to the, with the help of this control unit to the control bus. Like this it will be performed. But this is related to the block diagram. But how it will be done internally with the help of the diagram, which is mentioned in this first diagram, which is we are going to see. So first thing is that, as I said, that the, for example, control signals will be generated by the particular instructions. So first task is that from the control register, instruction register, instructions given to the control unit. How it will be done? So instruction register comes in the existence, that will be given to the control unit. Then control unit generate the control signal, which is mentioned here. Then here input is what is given as input, clock is given, clock given here. Then whenever first instruction is given to the control, that first instruction address will be stored in a PC, that is a program counter, which is we can see here. This will be a program counter, which is going to hold the first instruction's address is given to the MAR, that is a memory address buffer. That first instruction address will be stored in a memory address register. After storing this address in the memory address register, next instruction is going to fetch. That program counter content will be incremented and first instruction data will be stored in the memory buffer register. First instruction address is stored here. Here address memory address register and memory buffer register data is stored. So it will be start executing the particular instruction. Whenever instruction starts executing, it will be checked whether it is a arithmetical instruction or logical instruction. According to that, control signal will be generated. Then after execution of this particular instruction, result is generated, which is stored in the this register, which is called as a accelerator. That is a working of the control unit. Now, how this step by step will be done, which is explained with the help of this CPU internal bus. First thing is that whenever you want to perform any operations, so control register comes in existence. In that, for example, I want to execute the first instruction. Okay. So first instruction should be bring into the instruction register. That is a we have to do. Then that means we can give the input from the input devices and processor will be stored that in a form of instruction in the instruction register. That is given to the control unit. Control unit perform operation on that particular first instruction and result will be generated. But before generating the result, what are the internal tasks which is done by the processor, which is mentioned here? First is instruction is bring into the instruction register. Then second thing is after instruction is available in the instruction register, that instructions, first instructions address will be stored in the program counter in this, that is a PC. First instructions is available in address instruction register, then its address will be stored in a program counter. That is the second task will be done. After that, this program counter, the address will be bring through the memory address register on the address line. That first instructions address bring through the memory address register through the on the address line. Then after that, we need to perform the operations on the data. So first instructions, whatever operations we want to perform, that data is available in the memory buffer register. And that memory buffer register, it is holding the first instruction data. After performing that task, first that data will be stored in the first one register is compulsory accumulator. So it will be stored in the accumulator. That is we have done. And then first, for example, first register A is that is the accumulator, which is nothing but the Y register, and destination register is Z register. For example, here consider. Then control register perform that particular operation and final result is generated in the control register only, that is in the accumulator, and that will be stored here. So like this, that is the first thing is bring first instruction in the instruction register. That is the first task. Second, that first instruction address will be available in the program counter. Then that address will be sent to the address through the address line through the memory on the address line through the memory address register. Then first instruction data is available in the memory buffer register, which will be bring on the data line. That is the fourth step. Fifth step is one of the registers. Whenever we are doing any operation, one of the register is compulsory accumulator, which is going to hold the current value as well as the results of that particular instruction which is executed. and then result is generated and that result will be stored. Like these 6 steps are going to perform with the help of the control unit. Now all of you understand this one? All of you understand this? How control unit is going to work for the single instruction? This will be n number of instruction, n number of times simultaneously. Yes, okay. I will go to the next PPT. Now, next is what are the different operations which is going to perform with the help of the control unit. There are 5 types of operations which is going to perform with the help of the control unit. First one is instruction sequencing. How instructions are going to sequence means, for example, instruction cycle is having 3 pages, that is a fetching, decode and execute. These are the sequence of the instructions, or you have to maintain the sequence of the instructions. Then if you are having any branching operations, how it will be handled. If you are having micro operations, how it will be handled. Then if any interrupt is occur in a particular uh, operation is going on, then how it will be handled, and then instruction cycle. Like this, 5 operations will be done by the control unit, which is we are going to see in the next few PPTs in detail. For example, one is the instruction sequence, how instruction sequence are done. So instruction sequencing will be done in a form of the instruction micro operation. Each instruction is divided into the number of parts. So as I explain you, for these instructions, central processing unit, that instruction cycle has a number of pages or steps which is we are going to perform. In that first phase is that fetch. That means instruction is fetching from the memory or processor for the execution. In whether it is a direct addressing or indirect addressing, it will be identified in that phase. Then next phase is execution phase, and last one is if while executing, if any interrupt is occurred, then this interrupt stage is required. Otherwise, if no interrupt is there, then only 3 steps are there. If interrupt is there, then 4 steps are there or phases are there in a instruction cycle, which we need to perform the operations on the processor. Now, whenever we are performing these micro operations, each thread we need to require some moderate some amount of data, and that data is in a form of automatic or any operations which is we are performing on the CPU. That operations we need to perform. So how it will be done, which is explained in the next slide. For example, we need to execute the one program. Simple, you can say that the C or C++ programming language program you have written. Program is executing. Then whenever program is executed in of the instruction cycle. So clock cycle, clock per cycles, instruction cycle, it is executed. For example, if I'm considering one program is there, in that instruction cycle is there. As I have explained you in previous PPT, instruction cycle consists of the micro operation, and that micro operations consist of the 4 stages of instruction cycle of micro operation. First phase is fetching, that is a fetching that micro operation, and that will bring into the memory. Then after fetching that particular instruction into the from memory to the processor, that time it will be identified whether it is a direct address or indirect address, which is we have seen the direct addressing and indirect addressing mode of instructions. That will be identified. Then that particular instruction will be executed, and after execution or in between execution, if we found that some interrupts are occur in between, that interrupt will be generated and operation will be performed here. If not, then it will be go to the next step, which is may explain in this next PPT. As we have seen that the micro operation is having the 4 phases of instruction cycle. So what are the different types of micro operations which is we are going to perform? First thing is we are going to transfer the data between the register. That means in between the 2 registers we can transfer the data. For example, move A comma B. That means content of B register we are moving to the A register, which is we have seen in a first unit itself. Move A comma B. Content of B register move to the A register. register. That is a data transfer between the register. Then next one is data transfer from register to the external. For example, if you are saying that you want to transfer the data to the external devices or external memory location. For example, if I am saying the move 2000, that is the memory location of A, comma A. That means whatever contains in A register, that will move to the memory location 2000, which is a external memory location, or you may say that the internal memory location. Then transfer from the external to the register. For here, source become destination, destination becomes source, like previous instruction. Move A, comma 2000, it is the reverse way. That means 2000 is external memory location. In that memory location, whatever data is there, it will be moved to the A register. Like this, micro operation will be performed. Now next one is perform arithmetic and logical operations. Arithmetical operations, which is have n number of time, that is addition, subtraction, then multiplication and division. These are the operations which is we can perform here. And or operation, we can perform and or logical operation, and or mainly we can perform with the help of this micro operation. Now whenever we want to perform these micro operations, how it will be generated with the help of control signal. To control the micro operations, we need a control signal, and control signal, first signal is clock. Clock is used for the check the time, or you can say that it will be used measuring the time required for the executing the particular micro operations. So clock per cycle, like this, we can measure the particular instruction execution time. So one micro operations per clock is required. Then next one is we require a next control signal, that is a instruction register, which is a opcode of the current instruction. That is, it is going to hold the hex value of that particular instruction, and which will be determine the micro operations, which micro operations we need to perform. That will be with the help of the instruction register. Now next control signal is, which is most important, flags. It will be show the state of the processing unit or central processing unit, what is in which state. It is in execution stage, it is in a fetching stage, or it is in a calculating whether that is a direct or indirect addressing mode phase, or it is in an interrupt state. Like this, according to that, flags are going to set, which is mentioned in this PPT. Now, as well as it is going to hold the result of the previous instruction operations which is we have performed. For that purposes, flags are used. Now next control signal is control bus. Control bus is mainly it will be give you acknowledgement of the particular operations, whether it is a read or write operation, which is we are performing on the input output devices or memory devices. For that, it is give you acknowledgement. And second task is which is most important, whenever any interrupt is occurred in the systems, that interrupt is handled by this control bus. Now moving to the next part, again control signal output, that is a related input. So control signal output within a CPU, what are the tasks we need to perform? Control signals, that is will be a whenever control signal output control signals are generated, it is mainly causes the data transfer between the processor to memory and memory to processor, or memory to IO devices to the memory. For that purposes it is used, and activate the specific type of functions. Now next thing is that whenever we are performing the output signal as a control bus, that time it is going to via memory or IO modules. That means control signal is mainly generated for the memory to and from data you want to perform in. That means transfer and receive the data from memory to processor, processor to memory. For that, memory will be done with the help of the control bus only. And whenever we are transferring data from input output devices to the processor, or processor to memory, or memory to processor, that time again we require a control bus. That type, that will be a external signal which is required for this operation. Now next one is how these particular instructions are going to be executed, which is we are going to see. Previously, I explained with the help of the PPDs theoretically. Now we are going to see the actual. First thing is that as we are saying that the instructions are where first instruction is going to fetch the instruction fetch cycle. That is instruction cycle is here. Instruction is going to fetch by the fetching unit. It will be go to the next level, that instruction fetching micro operations, that is a indirect phase. In that indirect phase, it will be checked. This will be a second phase, okay, and first phase is fetching. It will be checked whether it is a direct addressing or indirect addressing. If it is a indirect addressing, it will be go to the again the instruction cycle. Again, if it is indirect addressing, in this indirect addressing, it will be go here, read that particular address, and result will be generated, and that result will be provided to the control line, and that will be sent to the particular device again to perform the next task. If not, if address is not indirect, that means that result will be generated and it will be displayed on that particular devices. Now next thing is that after performing, first phase is fetching instruction, second phase is in indirect phase. Now third phase is, that is a execution phase. Now after performing, whether that particular instruction is direct or indirect, again we that is in the execution phase. That particular instruction is going to execute it. That instructions opcode will be generated, that is a hex code will be generated, and instruction is going to execute it. Then result will be generated, that will be a file. But while executing the instructions, it found that some interrupts are occur. Instruction is executed, it will be stop that operation in that step only, and it will be interrupt that particular services. The interrupt service routing is called, and in that interrupt service routing, if this interrupt is there, that according to that operation will be performed and result will be generated, and again it will be given to here. If not, if you are performing the instruction execution here, if no interrupt is there, that directly result is generated here. And then if that instructions require any interrupt service routing call or any setups is required, that will be done with the help of the like this. The micro operations of the total instructions will be done, which is explained in the theoretically in previous PPT, and here practically, which is shown with the help of the diagram. Any doubt in this? Doubt? No doubt? Okay, I will go for the next PPT. Now, whenever we are performing the operations in the control unit, there are some control register which is we are going to utilize for the operations, which is I have shown in the first diagram itself. That means first thing is that we have to perform the fetch operations. In 4 control registers are used. First control register is program counter. Already I have explained, it is going to the address of the next instruction which is to be fetched. Then next register is, second type of register is memory address register. In short, in that diagram I have done which is connected to the address bus and which specifies the address of the read or write operation which is we want to perform. That means it is going to hold the address of the next instruction which is we are going to execute. Now next register is control register is memory buffer register, which is going to hold the data, which data we want to write or which data we want to read, that is held by this memory buffer register. and it is connected to the data bus, which is also I have explained with the previous PPT only. Then last type of register is used in the control unit is instruction register, which is going to hold the last instruction which we want to fetch. That is going to hold by this processor. Now next thing is how this fetching can be done, which is all these operations, fetching and all the phases, these operations, how in detail we are going to see in the next few PPTs related to this register only. Now cycle is there, fetching cycle. So for fetching cycle, what is it will be done? Diagram previously, which is I have explained that diagram. Same diagram I have kept here and a description. So first thing is that it is going to first address of next instruction is in PC. So first instruction is available in the instruction register. So the first instruction brings to the program counter. That means in that first instruction address will be stored in the program counter. Then address is placed on the address bus. That means address will be placed on the address bus and that will be sent to the memory address register, which is shown here. Program counter content will be moved to the memory address register. Means in program counter register, initially first instruction address is stored and that address will be then sent to the memory address register. And that memory address register is nothing but it is an address line of that particular processor. That will be done in a T1 time. That is a time required for the timing cycle of that particular instruction, which is mentioned by the T1, T2, T3 like that. Now, next control signals issues a read command. So, we want to read the data for this first instruction itself. So, we go for the next page, that is a result or data from the memory appear on the data bus. So, result is appear on the data bus. What do you mean by that? That means whatever data is there for the first instruction, for example, for first instruction, that data will be bring to the memory buffer register. That means on the data lines, that will be bring from the memory. So memory is on the control unit. On that memory, that will be transferred to the memory buffer registers. So that particular instruction, whatever data is there, for example, if considering here, move A comma B. For your understanding, I am taking one example. Initially, for example, this is a first instruction and instruction is stored in the memory address 2000 memory location. So what is the value of program counter? Program counter is having value 2000. Then that 2000 value is bring the memory address register. That will be bring on the address lines. Then control signals will be read that particular data. So what is the value in A register? For example, A register is having value 2 and B register is having value 3. Okay. And we are moving or you can say that A register is having value 0 and B register is having value 3. So what is going to happen whenever this instruction of B register will be moved to the A register? So first of all, address is moved. Now, third step, read data from memory appear on the data lines. So what is the data? 2000 is address line. Address line will be read. So what is your data? 3 is your data for that first instruction. That will bring on the these memory buffer register, which will be sent to the on the data lines. So in 2000 memory location, memory address registration register location, 3 data is stored of the B register that will be bring to the memory buffer register. That will be done in a T2 cycle. Now next thing is that after performing these operations, program counter value will be incremented by 1. So program counter, what is program counter is having value 2000. So 2001, that memory value will be incremented by 1. Next thing is that the instruction register content will be moved to the memory buffer register. From the, sorry, data move from the memory buffer register to the instruction register. What is the data in memory buffer register, which is I have mentioned here? 3. This 3 data is bring to the instruction register. So instruction register is having value 3. Now after that, next register value will be whatever arithmetical and logical operations which is we want to perform here, that will be done, and final result is generated in a memory buffer register itself, that is in a accumulator only. Data is fetched for the particular memory location. Like this fetch cycle is going to work. All of you understand this or any doubt? Any doubt? No? Then we will move to the next cycle. In the phase cycle itself. Here I have taken the both the diagram, which is we have seen in the previous PPT. When in that phases are there. First one is phase, then indirect, then execution, and then interrupt. Like these are the 4 phases of the instruction cycle. So how this phase cycle is going to work with the help of these 2 diagram, which is mentioned here. Fetching cycle, how it is going to work. So first thing is that program counter content will be moved to the memory address register, which is also I have mentioned in a previous PPT also, but in that description itself, it is mentioned with the help of the same color. Now, so program counter content will be moved to the, or you can say that it will be moved to the memory address register. Then memory contents will be moved to the memory buffer register. Memory is what? Accumulator. It will be moved to the memory buffer register. Then program counter will be incremented by 1. For example, in previous case, which is we are seeing that the memory count program counter is having value 2000, so it will be incremented by 1, that is 2001. Then memory buffer content will be moved to the instruction register, that is done in a third cycle. Here also we can see the first of all instruction is fetch. That instruction will be fetch. First instruction is fetch. That first instruction address is stored in the instruction register. Whenever this instruction is fetched, that address will be stored in a program counter, which will be bring to the address line through the memory address register. Now we will go to the next step, that is the indirect addressing. Whenever this memory address register is having its first instruction address, then it will be identified with that whether it is a direct addressing or indirect addressing. It will be identified that there only. If it is a direct addressing, then it will go directly here. If it is direct addressing, that means that that particular memory contents will be moved to the memory buffer register. So memory, whatever first instruction data is there, that will be moved to the from accumulator to the memory buffer register, and program counter will be incremented by 1. And then data will be stored in the memory buffer to the instruction register for the execution of the operation, which is done in a control unit. Same here. Whenever this data goes to the control unit, that means that instruction start executing here. That is the execution operation which is we are done here, and that instruction is executed and result will be generated here itself. If interrupt is there, then interrupt will be occur, that interrupt will be executed, and then final result will be generated. Like this, these operations are correlated to each other. Fetching. Any doubt in this? Any doubt in this? Okay, I will go for the no doubt. Now we are performing cycle. Whenever we are saying that we are having the interrupt is there, still cycles are whatever data operations we are performing, which is equal, which is mentioned here. Timing unit is same required for the PH cycle. Then whenever we are using the clock cycle into the number of groups, that is a T1, T2, T3. How these properly it is executed, which is mentioned here, same explanation is there, which is I have explained in previous PPT. Now we are moving to the instruction cycle next phase, that is the indirect cycle. Now in indirect cycle, how it is going to done? So first thing is that the address register is holding the address of that particular instruction, which will be bring to the memory address register. In previous case, what is done? Instead of this, program counter is there. Remember, that is the difference between indirect and fetch cycle. In fetch cycle, directly program counter content will move to the memory address register. But here, direct cycle, memory address, instruction register address will be bring to the address register. That will be done in the first page. Then memory content will move to the memory buffer register, and memory buffer register address will be moved to the instruction register. Again, in a third T3 changes are there. Here we have changed the instruction content will be address will be moved to the memory buffer register. That is, we have done that. These are the two changes which is done in a indirect addressing mode. That is, we have done. If you not understand, please tell me. I will repeat again. Indirect address, all of you understand? First difference is that in indirect addressing cycle, if you see the of this first interrupt cycle, this one, instruction address register is moved to the memory address register. Here we had done the, instead of this, program counter is there, and memory program counter content will be moved to the memory address register. That is the first change. And second change is content of memory buffer register instruction register content move memory buffer register, but here it is a reverse way. Memory buffer register address the instruction address register. These are indirect addressing mode. In indirect addressing mode, whatever in the instruction itself, address is given indirectly, and we have to move content to the that particular memory address location, which is we have seen in a addressing mode itself. That's why we had to do like that. Now next, interrupt cycle. Whenever we are having the any interrupt which is occurred in the system, first cycle, that is a program counter content will be moved to the memory buffer register. Then address is saved on the address memory address register, and program counter routing address will be stored in a program counter itself. That means the currently whatever operations we are done, that current address will be held by the program counter, and the address is stored in the memory address register. Then memory buffer register content will be moved to the memory locations. That means here interrupt is occurred in that places. Direct memory will be stored in that particular memory buffer registers content. That means here direct addressing will be done from the with the help of this interrupt cycle, which is mentioned here. Now next one is how this will be done, which is again repetition is there. As first of all, instruction address will be moved to the memory address register. That means in the instruction register, whatever address is there, it will be moved to the memory address register. Then it is mentioned with the help of this add R1 comma X. That is, the X is nothing but a memory location, and R1 is one register. Then memory is nothing but the content data available in that particular memory location, which will move to the memory buffer register. That is will be done. Then memory buffer register plus register R1, that content will be added and result is generated in R. Here Okay, X is nothing but the memory buffer contents, or you can say that the memory location is there, which is indicated by X. So here add, for example, it is like there, comma A, comma B. As I explained, add A, comma B. How this instruction is going to, it will be adding the content of A register with the B register, and final result is stored in the A register. Like this instruction is work. So which is mentioned that R1 is equal to R1 plus MBR, that is the X memory register content. Like this is going to execute it in add R1 memory. One is execute ISZX. How this is micro operations, single micro operations, which is we are going to see. First of all, the X is, as I said, that the memory location or content of that particular data. Instruction register address moved to the memory address register. Memory X memory, which will be moved to the memory buffer register. Memory buffer register content will be incremented by 1. This instruction is used for the increase and skip if 0 is there. That means the content will be incremented by 1, and if it is if after incremented the value, if it is having the 0 value, we have to skip that value. If not, then we will add the 1. That's it, which will be done here. Then here memory buffer content will be moved to the memory. Then we are checking after moving, incrementation operation will be done. Then we are checking the content of memory buffer register is equal to 0. Then program counter can be incremented by 1. If it is 0, then we have to skip. If not, then we have to increment that value, which is mentioned here. Now same type of execution cycle for the next instruction, branch and address. Next instruction which is given, n number of instructions are there. An example here, branching means we are putting the loops for the particular instruction. That's like a previous example. Now control, which is we have seen in a previous PPT, all these 4 diagram which is in the single PPT, and how these particular control signals are generated in a phase cycle. What operations we have performing, that is mentioned here. You have to remember with respect to all these 3 diagram. First thing is that the whenever control signal is of micro operation, fetch operations, we are in a fetching the instruction. What will happen? Program counter content will be moved to the memory address register. Memory content will be moved to the memory buffer register, and program counter value is incremented by 1. After incrementation of value, memory buffer, first instruction, data is available in a memory buffer register, which to the instruction register. That is done in a phase cycle, which is also I have explained with the help of the all these diagram. Indirect, this if you remember this table, you can easily write down the description. In indirect addressing, if you are having indirect addressing, that is first of all is available in the instruction register, and that instruction register is holding the address of that particular instruction. We move to the memory address register, then memory content will be moved to the memory buffer register. Then memory buffer, whatever memory buffer data is stored in particular location, that is available in memory buffer register address instruction register, because here address is going to move, not content. In previous case, MBR moved will be moved. In phase cycle, content will be moved, and indirect cycle address will be moved. In that particular address location, whatever data is there, that will be moved to the one address location to the another address. Indirect address instruction cycle. Now interrupt cycle. In that interrupt cycle, as like first one, program counter content will be moved to the program buffer register. That means program counter is holding the address of that particular instruction. In that instruction, whatever data is there, that data will be actually moved to the memory buffer register, not address. Here. Now, in case of interrupt is occur, then save that address in a memory address register, and routing will be called by the program counter, and that is called by the program counter. And lastly, content of memory buffer register will be this memory buffer register will be moved to the memory. That means interrupt is occur whenever we are having the memory related op. That's it. Now, simple how the control decoder operations will be done, which is also explained in this diagram previously also is represented here. Same previous this one that is also again separately I have put and explain how these operations were done. That's it. This is the end of your basics units of the process basics of the processing unit and block diagram of processing unit. Third thing, working of the processing unit. These three topics I have covered. Now in the next lecture we are going to see the processing unit types. That is the control processing unit types. There are two types of the processing unit. That is a hardware control unit and micro program control unit. In tomorrow's lecture, we will see the hardware control unit and next lecture, micro control unit. Any doubt till? Any doubt, students? Student, any doubt? No? Shall I end the session? Okay, thank you.